Let's solve equation chapter 2 E1. Traveler covers the distance of 460 miles in a time of 8 hours, and what is average speed for this travel? So velocity or speed, average velocity or speed, and the distance divided by time. So 460 divided by 8 hours, 460 divided by 8, then you will get 57.5 mile per hour. That is your answer for number 1. Let's solve number 2, which is a worker covers a distance of 1.8 kilometer in time of 30 minutes. What is average speed of workers for distance in kilometer per hour? So speed and 1.8 kilometer and 30 minutes means 0.5 hours. Then you can do 1.8 divided by 0.5. Then you will get 3.6 kilometer per hour. That is your answer. So this 30 minutes equal as half an hour, which is 0.5 hour, and then you can solve straightforward. Okay, let's solve number 3, which is E3, and the grass clipping the found to have the average length of 4.8 centimeter when a lawn is moved 12 days after previous mowing, and what is average speed in growth of the grass centimeter per days. Okay. Yep. So this is also speed, average speed, and then you will get the 4.8 centimeter over how many days? 12 days. So 4.8 divided by 4.8 divided by 12, then you will get 0.4 centimeter per day. That is your speed, average speed in a day. Okay, the next question should be a driver drives 2.5 hours at an average speed of 54 miles per hour, and the distance does she travel in this time? So the distance equal your velocity, average speed, times t. So your velocity, average speed, is 54 miles per hour, and then travel 2.5 hours. So 54 times 2.5 becoming 135 miles. That is the travel for 2.5 hours. Okay, let's continue. Number 5. A woman walks a distance of 240 meters, average speed of 1.2 meter per second. What time was she required to this distance? So you need to find the time, which is distance divided by velocity, right? Then you will get distance is 240 meters, and your velocity or average speed supposed to be 1.2. So 240 divided by 1.2, and you will get 200 seconds to travel, to walk, and then you can reach 240 meter. Okay, the next question is the E6. A person in a hurry in average 62 miles per hour on travel covering distance over 300 miles. What time was required to travel that distance? So time also same, the distance divided by average speed, which is 300 miles divided by 62 miles per hour. So 300 divided by 62. Then you will get 4.84 hours. That is your answer. So just you need to calculator to use this calculation. Okay, the next one is a hiker walks with average speed of 1.2 meter per second. And what is the distance in kilometer does the hiker travels in time of 1 hour? Okay, 1 hour. How many seconds you need to convert? 1 hour is how many minutes in 1 hour? 60 minutes in 1 hour. And how many seconds in 1 hour, 1 minute? So 60 seconds in 1 minute. So hour cancel out, minute cancel out. 60 times 60 is 3,600 seconds as your 1 hour. This is 1 hour. And the distance equal as the average speed times t. Your average speed is 1.2 meter per second times t is 3,600 seconds. So 1.2 times 3,600. Then you will get 4,320 meter, but they want to get in kilometer. So you can change meter. 1 kilometer equal as how many meter? 1,000 meter. And meter can cancel, and then you will get 4.32 kilometer as the distance for travel in 1 hour. Okay, I will. Okay, next one is E8. A car travels with average speed of 22 meter per second. What is this speed in kilometer per second? And what is speed in kilometer per hour? Okay, it's a unique conversion. Okay, 22 meter per second. Then you need to change it to kilometer per hour, then per second, right? And then you just need to convert meter to kilometer. How many 1 kilometer holding how many meters? 1,000 meters. And then meter cancel out, and then you can change 22 divided by 1,000 becoming 0.022 kilometer per second. Okay, good. And we need to convert kilometer per hour now. 0.022 meter per second. And you already knows in previous equation how many seconds in 1 hour? 3,600 seconds in 1 hour, right? So second and second is gone, and then meter per hour, and then right, this is kilometer per hour, right? So 0.022 times 3,600, then you will get 79.2 kilometer per hour. So which means 22 meter per second as original becoming 79.2 kilometer per hour. This is unique conversion. Okay, the next question is a car travels with average speed with 58 miles per hour, and then what is the speed in kilometer per hour? Okay, 58 miles per hour. Change to kilometer per hour. How many kilometers in 1 mile? 1.61 kilometer in 1 mile, right? And then you just cancel this unit, miles and mile, and then you multiply 58 times 1.61, and you will get 93.38 kilometer per hour. This is 58 mile. Okay. Okay, the next question is E10 on chapter 2. Starting from the rest to moving in straight line, a runner achieves a velocity of 7 meter per second in a time of 2 seconds. What is average acceleration of the runner? Your acceleration, you can define delta V over delta T. It says from the rest to becoming 7. We call this one as V0 and this one is V1, or other way around, V2 and V1. Then V2 minus V1 over T2 minus T1 is for 2 seconds. 2 seconds, right? Which is 7 meter per second minus 0 meter per second divided by 2 seconds. Then 3.5 meter per second square as your acceleration. Okay. Okay, the next question is 11. Starting from the rest, a car is accelerated rate of 4.2 meter per second square for time of 5 seconds. What is velocity and of this time? So your velocity equal as V0 or V1 plus AT, right? So V0, this one is we call as V0 as last, which is 0 meter per second. And then acceleration is given. Acceleration is 4.2 meter per second square. Time is given as 5 seconds. And your V0 given as 0 meter per second, right? And then you plug in and then you will get your final velocity, 0 meter per second plus 4.2 meter per second square times 5 seconds. Then you will get 4.2 times 5, and 21 meter per second as your final velocity. Okay, the next question should be E12. The velocity of a car decreases from 30 meter per second to 18 meter per second in 4 seconds. Okay, what is the average acceleration on this process? This we call it V1, this we call it V2, this as T. Okay, V2 minus V1 over T, which is your acceleration. V2 is 18 meter per second minus 30 meter per second over 4 seconds. Then you will get negative 12 meter per second over 4 seconds, which is negative 3 meter per second square, which is your acceleration. The negative means deceleration. Okay, the next question is E13. A car is traveling with initial velocity of 12 meter per second and the constant rate of 2.5 meter per second square for 2 seconds. Okay, so this initial velocity we call as V0, and this is A, this is T. Okay, and then what is velocity end of this process? V equal V0 plus AT, which is V0 is 12 meter per second plus a equal 2.5 meter per second square. Then t is 2 seconds. Then you will get 12 plus 5 becoming 12 meter per second plus 5 meter per second becoming 17 meter per second. 17 meter per second as final velocity. And what is distance does the car traveling during this process? The d equal d0 plus v0t plus a t squared and half, right? So d0 equals 0 and v0 12, right? 12 meter per second, and the time is 2 seconds plus acceleration is 2.5 half times 2.5 meter per second square, and t equal 2 seconds 2 second square. Then you will get this is a 24 meter plus this becoming another 5 meter, right? 2 squared is 4, 4 divided by 2 is 2, 2 times 2.5 is 5 meter, becoming 29 meter to travel for in 2 seconds with this acceleration and initial velocity. Okay, the next question is a runner travel with initial velocity of 2 meter per second, which is a v0, and accelerated at the constant rate of 1.2, which is a, and the time of 2 seconds, this is t. So what is his velocity at the end of this process, this time? So velocity equal as v naught plus at. So v naught is 2.0 meter per second plus a is 1.2 meter per second square time 2 seconds. Then this is 2, this is 2.4, 2.0 meter per second plus 2.4 meter per second, then 4.4 meter per second as the final velocity. And what is distance does the runner cover during this process? The distance equals d naught plus v naught t plus half a t squared. So d naught is 0 meter, v naught is 2 meter per second. How long? 2 seconds. Plus half times a, acceleration is 1.2 meter per second square, and the time is 2 seconds square. Then you will get 4. This is supposed to be 2.4. 4 meter plus 2.4 meter becoming 6.4 meter. Okay, that is your answer for this traveling. Okay, the next one is a car is moving on initial velocity with 30 meter per second, which is your v0, v naught, and it says slow down at the constant rate of 3 meter per second square. It's a slow down, which is your acceleration, and that acceleration is slow down means equal negative 3 meter per second square. Okay, the negative means slow down or deceleration. So what is the velocity after 3 seconds of deceleration? Okay, so velocity equal v naught plus at. So velocity, this is t, right? T equals 3 seconds. 30 meter per second as initial velocity plus a equal negative 3 meter per square. How long it travel? 3 seconds. 3 times 3 is 9, negative 9. So 30 meter per second minus 9 meter per second, because it decelerate 21 meter per second as your velocity. What is distance covered in this time? Then your distance also same t0 plus v naught t plus half a t square. Then d naught is 0, v equal 30 meters per second, and the time is 3 seconds, plus half times negative 3 meter per second square times how long? 3 seconds. Okay, square. Then 30 times 3 supposed to be 90 meter plus 3 times 3 square supposed to be 27 divided by 2, so negative 13.5 meter. Okay, is it correct? Yes. 90 minus 13.5, then becoming 76.5 meter as the distance traveled during this time. Okay, the next one is a runner is moving with initial velocity of 4 meter per second. Slow down at a constant rate of 1.5 meter per second. A equal negative 1.5 meter per second square over a period of time as 2 seconds. T equal 2 seconds. Right? And what is the whole velocity end of this time? Velocity equal v0 plus at. v0 equal 4.0 meter per second plus a equal negative 1.5 meter per second square times how long? 2 seconds. So this is 4 meter per second minus 3 meter per second equal 1 meter per second after the slow down, which is the deceleration. Okay, what is distance travel this process? v0 plus v0t plus half a t square. t0 is 0 meter and v0 is 4 meter per second, and how long? 2 seconds plus half a equal negative 1.5 meter per second square times how long? 2 seconds square, which is this could be 4 divided by 2 becoming 2 times the negative 1.5 becoming negative 3 meter, and this becoming 8 meter, then becoming 5 meter all together during that slowdown. Okay, thank you. Okay, the next question is E17. And if a world-class sprinter ran a distance of 100 meter distance, d equal 100 meter, starting at his top speed of 11 meter per second, and running with constant speed throughout, and how long would it take him to cover the distance? Okay, so this is how long, and find the time, right? Time equal the distance divided by velocity or average speed, top speed, which is 100 meter as a distance, and this is the top speed, 11 meter per second. So 100 divided by 11, then 9.09 second, 9.09 seconds to reach 100 meter. Okay, the next question is 18, which is the last on chapter 12, chapter 2, and then starting from rest, a car accelerates at a constant rate of 3 meter per second square for time of 5 seconds. right? This is acceleration, this is time, and then compute the velocity at the car 1 second, 2 seconds, 3 seconds, and 4 seconds, and 5 seconds, and plot the velocity value against the time graph. Okay, so let's find the velocity 1 second equal initial velocity is rest, so initial velocity 0 plus at, 0 plus a equals 3 meter per second square times 1 second, then which is 3 meter per second. v 2 second, same, 3 meter per second square times 2 second, then 6 meter per second. v3 equal same, 3 meter per second square times 3 second, which is 9 meter per second. v4 supposed to be same, 4 second, and 12 meter per second. v5 equals 0 plus 3 meter per second square times 5 second, then 15 meter per second, which is, you can draw the graph. This is velocity, which is in meter per second, and this is time, which is a second, SEC. And then we can put 1, 2, 3, 4, 5, and we can put 3, 6, 9, 12, and 15. 0, 1, 2, 3, 4, 5, 3, 6, 9, 12, 15. Then 1 second is here, 2 second is here, 3 second is about here, 4 second is about here, 5 second is about here, and then you can draw it. This is your VT graph. Okay, then compute the distance traveled by the same time and plot the distance value against the time, which is your distance equal same, v0 t plus at. v0 is rest, no need. Only you need to calculate the half times 3 meter per second square times 1 second square for 1 second, then which is 1 second square is 1, and then 3 divided by 2 becoming 3 over 2 meter, or 1.5 meter. t2 supposed to be same, 3 meter per second square times 2 second square. 2 second square becoming 4, 4 divided by 2 is 2, 2 times 3 becoming 6 meter. And d3 becoming half, 3 meter per second square, then 3 seconds square. Okay, 3 square is 9, 9 times 3 is 27, divided by 2 becoming 13.5 meter. d4 becoming half, 3 meter per second square times 4 seconds square. 4 seconds square is 16, 16 divided by 2, 8, 8 times 3 becoming 24 meter. And d5 is same, half, 3 meter per second square, 5 seconds square. 5 square becoming 25, 25 times 3 becoming 75, 75 divided by 2 is 37.5 meter. That is your in time, and we can draw T1, 2, 3, 4, 5 as 1 2 3 4 5 as t second, and we can draw 10 10 20 30 40 10 20 30 40, and this is the distance as meter. Okay, 1 second is 2/3, is very small, tiny, and 2 second is 6 meter, over here. 3 second is 13.5, about here, and 4 second is 24 meters, about here. 5 second is 37.5, about here, right? And you can draw this way as your graph. This graph we call as a quadratic. This is a linear graph, you can see. Okay, that is number 18. So I will see you later.